Hello again, and welcome to Organic Chemistry Lab. And today we're going to do experiment number 5, and distillation. Now, when you read the lab menu in chapter 5 there, it's just distillation. Now, since we got this, when we moved into this new building, we got some brand new instruments there, so we're going to incorporate gas chromatography into this particular lab activity. So our objective is to learn how to perform distillation, whether it's simple or fractional distillation in the laboratory setting. And then once we finish the distillation, we collect the distillate, and from there we want to analyze the distillate, each of the sample that we collected. We want to analyze it by using gas chromatography and then trying to figure out which process is more effective in terms of separating the liquids there. So distillation, this is probably a word that you hear in everyday life on a regular basis. And what is distillation? Well, distillation is a process that we can use to separate two or more liquids that are mixed together. Based on one condition, that those two or more liquids there, they should have a sufficient difference in terms of their boiling point. Now, compared to the previous experiment there, we're talking about the melting point. Melting point refers to a temperature range. Boiling point is a single temperature point. And of course, boiling point has something to do with the air pressure and all that, but at a given pressure, in the 1 atm for example, and the boiling point of water is 100 degrees Celsius, okay, or 212 degrees Fahrenheit. And that boiling point for different liquids at a given pressure is always going to be a constant. So here, what we're trying to do, and if you have two or more liquids mixed together, and if you heat it up, that mixture there, the one with the lower boiling temperature will start to vaporize first. As a result, that vapor is leaving the mixture of the liquid and is getting out of the mixture there. And if you direct that vapor through a series of channels where you can actually cool it down, condense it back into the liquid, we can achieve our goal of separation. Okay? So these are the two things we're trying to do. And in terms of the chemicals that we're working with in this particular experiment, we're using cyclohexane, carbon-6, hydrogen-12. And we're using methylbenzene or toluene, and carbon-6, hydrogen-5 with a methyl group. Or if you want to write it as carbon-7, hydrogen-8, you can do that as well. What's important about these two chemicals, in addition to their formula, the name, the structure, the molar mass, what's relevant for this particular experiment is that their boiling point. So cyclohexane has a reported boiling point of 81 degrees Celsius. And methylbenzene has a reported boiling point of 111 degrees Celsius. So you can see they're 30 degrees apart from one another. And even that, since these two organic liquids are soluble in one another, when you try to do distillation, you can never completely separate them. Okay? And you can only achieve partial separation because they are soluble in one another. And when the vapor of the sample, of one of the sample is coming out, that sample could actually take some of the other sample with it. Okay? Even though it's not boiling there, and it can be dissolved in the vapor there. And then in that case, you still have a mixture. So the question becomes, how do you get a pure sample? Well, in order to get pure sample for distillation, if that's even possible, is that you collect the distillate at different temperature and you repeat the distillation process over and over and over. And in some situations, even when you do that, you will not be able to completely separate the two liquids mixed together. Case in point, alcohol, ethyl alcohol and water. If you have an alcohol and water mixed together, those two molecules, they can actually interact with one another through Chem 101 again, hydrogen bonding, right? So those two molecules, they can interact with one another via hydrogen bonding. In that situation, we form something that we call an azeotrope. That is, the boiling point of that mixture is very close to the boiling point of the pure ethanol. Ethanol has a boiling point of 78.5 degrees Celsius. The azeotrope here, the mixture of water and ethanol, is somewhere around 79 degrees Celsius. So there is no way that you can get pure ethanol through distillation. Then how do we remove the water? We have other different methods there that we can absorb the water and subtract the water out of the mixture there. Okay? And so that is a different process there. And in terms of the distillation, for today's experiment there, when you write the lab report, once again, vaporization and distillation, it's a physical process. Okay, you're vaporizing a liquid there, and there's no chemical reaction equation, so you don't need to write that out when you do your lab report. In terms of the activity, we want you to perform simple distillation for a 1-to-1 mixture of methylbenzene and cyclohexane. And then we want you to perform a fractional distillation between a 1-to-1 mixture between methylbenzene and cyclohexane. And once we finish the distillation part, we will collect the sample and then we will put it into an instrument that we call gas chromatograph. Okay? And then we will analyze the sample. From the result of the from the analytical result there, we can actually figure out which one is more effective in terms of the separation between simple distillation and fractional distillation. So you ask, what's the difference between simple distillation and fractional distillation? In our laboratory setting, when you put all the glasswares together, the only difference between these two is that for the fractional distillation, we use some material that has a large surface area. We pack the distillation column. Okay? And then for the simple distillation, the distillation column is just an empty glass tubing. What happens there is that when the vapor of the liquid start to move up along the distillation column, the packed column will actually, because you have the material that has a large surface area, the packed column will actually slow down the escape of the vapor. And you see a repeated distillation on the packing material. And with the hope that will give you a better separation. And then for the simple distillation, once the vapor forms from the heating, it will just flow through that channel there. Okay? So these are the two possible differences. This is the difference between the two different processes that we have here, simple distillation versus fractional distillation. A practical application, why do we need to know how to do distillation? A lot of things can be done in industry. You drive cars, and car burns gasoline, right? So gasoline is actually a chemical distilled from crude oil. And when you have crude oil, you heat it up, and different components will vaporize at different temperature. And if you direct those different vapors through different channels at different temperature, you end up with gasoline, kerosene, and so on and so forth. Many different types of product there. And the beverage industry there, when you try to increase the alcohol content, you use distillation to remove water, right? After the fermentation process, you can actually use distillation to extract, if you will, take the alcohol out of the mixture there. So many different applications there. So this is something that we will do today. We will do in the lab today. We will get a hands-on experience of watching how we perform by doing these two different processes there. So we will go to the hood and then we'll do a quick demonstration about the distillation, and then we will let you put your hands on the instrument there, and we'll get started on the lab activity. All right, so this is the setup that we use in the laboratory to do distillation. Okay, so here we got two different chemicals, and this is cyclohexane, and then we have methylbenzene. Okay. One of the devices that I want to introduce to you is something that we call a condenser. In organic chemistry lab, we use different types of glassware. And if you look closely at this condenser, this is actually a two-layer glass tubing. Okay? And the inner layer is sealed from the outer layer, and the cold water can actually run through in between the two layers. So when the vapor of the hot solution, when you heat up the liquid there, when the vapor goes through the inner tubing, it's being cooled down or condensed back into the liquid by the running cold water on the outside. So this is this condenser that we want you to take a very good look at. And this end and this end, these are sealed. And then you have the water outlet, you have the water inlet. Okay, so for the setup there, we need a round bottom flask, we need a distillation column, we need a distillation adapter, we also need that condenser that we were talking about. And then at the end of the distillation, at the end of the condenser there, we have another piece of glassware to direct the liquid into a small container. So here we have a hot plate, we have a round bottom flask, This is a typical setup for a fractional distillation. In the distillation column here, we actually pack that column with some copper sponge. The reason that we use copper sponge is copper is relatively stable under heating, okay, and then it has a large surface area. So in this case, we took roughly about ½ gram to 1 gram of the copper sponge, and then we put it into the vertical column in the setup there. And then the liquid that we will distillate, that 1-to-1 mixture of these two chemicals, goes into the round bottom flask. Okay? And when you connect everything together, be careful. This is the laboratory that we have the most breakage there, and every time when I see the glassware dropping on the floor, it just makes me nervous, right? So you are putting multiple pieces of glassware together. We want you to do it one piece at a time. After two pieces are connected together, you want to make sure that you secure them with either a clamp or something else. And you don't want two pieces of glassware hanging, being connected to one another, hanging in the air with nothing holding them, right? So another thing we want to point out, in this particular laboratory, when we do activities there, all of these glassware, they have ground glass joints, meaning if you put two pieces together into one another, if you turn it about a quarter of a circle, they will provide an airtight seal. So that's something that that's very convenient. Otherwise, you will actually have to put the different types of sealant in between the connection to avoid the leaking of the vapor there. So this is the setup that we have here. We have our liquids in here, the mixture. Once we turn on the hot plate, well, and you also want to have the running water going through the condenser. If you look at the setup, it's tilted at an angle. So the water inline is always in the lower end. The water exit line is always in the higher end, so that the entire condenser can be filled with the cold water. So once you are ready, you can turn on the hot plate. In the meantime, you turn on the cold water. Cold water will run through the condenser, and then since the hot plate is heating, the liquid inside here will start to vaporize, and the vapor will move gradually up. Once the vapor hit the thermometer here, you are going to see the temperature going up drastically and reaching the boiling point of one of the two components in there. And then the temperature will stay stable there for quite some time. And then after all of the lower boiling point component is gone, then the temperature will go up. And then it will reach the boiling point of the next components in there. And then the temperature will stay there for a while until all of the liquid is gone. And as the liquid is moving, vaporizing, and moving through the condenser there, you have different containers that you can collect the distillate. So we ask you, for this particular experiment, we ask you to collect two different distillates. One around 80 degrees Celsius, the other around 110 degrees Celsius. And then once we finish the collecting those two distillates, we're going to take it and we're going to put it into the instrument that we call gas chromatograph. Gas chromatograph. We use abbreviation so often, we call it GC, right? So you put the sample in there and analyze the sample, and the instrument will tell you what is the percentage of each of the components in the two samples that you collected. So that is pretty much how we do distillation. This is the typical setup with the glassware that involved in organic chemistry labs, and I hope you will enjoy the lab activity and learn something about how to do distillation.